Every second, the sun emits a vast range of light waves. We can only see a minuscule part of these waves. But our eye cannot detect most light waves. Objects appear to have different colors, according to light waves they reflect. This leaf looks green because its composition reflects green waves and absorbs other light waves.
Light waves. They are the fastest thing in the universe. They travel at 300 million meters per second. In space, that is.
Light waves are like waves on the ocean.
There are long waves with low energy, small waves, and tiny but really fierce waves with very high energy. What if we can see only one color? Imagine, for instance, if we could only see things that were red and everything else was completely invisible to you. As it turns out, that's how we see all the time.
The energy of light stimulates the receptor in our eye, called the retina. Our retina is only sensitive to light with very small range of energy, called visible light. Light that is too high energy gets absorbed by the eye's surface before it can get to the retina, and light that's too low energy is not capable of stimulating our retina at all. Viewing the sun in multiple wavelengths allows scientists to understand and learn more about the world. But where do light waves come from? A vast range of light waves are created when atoms or molecules drop from a higher state of energy to a lower one. They lose energy and emit it in the form of radiation. Visible light is created when an electron that is in an excited state drops to a lower energy state and loses this excess energy. The same way, incoming light can elevate an electron to a higher state of energy by being absorbed by the electron. The moving charge of an electron creates a magic field, which creates an electric field. These two fields push each other in space, transferring energy from one place to another. Light waves have crests and troughs. The distance between crests is the wavelength. While some light waves are very long and measured in meters, many are tiny and are measured in billionths of a meter, a nanometer. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. 1 wave per second is called a hertz. These waves spread across the spectrum from very long radio waves that can have the size of a building to microwaves that have the size of a baseball. Infrared waves are as small as a pinpoint. In the middle, we have visible light waves, which measure in nanometers, from red waves all the way down to violet waves. At this point, wavelengths are so short, we talk about rays, from ultraviolet rays to X-rays that are roughly the size of an atom. Last but not least, we have the shortest but most powerful and fierce gamma rays. Long light waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest high-energy waves in the spectrum. This spectrum of invisible light is the foundation of the information age and of our world.